Hello and welcome to the class. I'm Shahid Ali and I'll be discussing wind and pressure belts on Earth. So as far as wind and pressure belts are concerned, these are the belts we have. You can see there are wind as well as pressure belts which are shown on this picture. First of all, if I talk about the wind belts in North Hemisphere, you can see there are three belts. This is the very first belt named trades or the trade winds. This is the first belt. Then this is the second belt called westerlies, and there it is the third belt called polar easterlies. So in the northern hemisphere there are three wind belts. Similarly in the southern hemisphere, these are the wind belts in the southern hemisphere named the trade winds, westerlies and the polar easterlies. So total there are 6 wind belts. And as far as pressure belts are concerned, total 7 pressure belts are there on the earth, on the surface of earth. Like the very first belt, this is called equatorial low pressure belt. You can see in red, this is equatorial low pressure belt at the equator. Then this is the second, it is near to 30 degree, it's 23.5 degree to 35 degrees around that, and this is termed as subtropical high pressure belt. This is second in the north hemisphere, and similarly there is another subtropical high pressure belt in the southern hemisphere, and this is the third belt we can see. Then there is a fourth one. This is at 60 degree, around 45 degree to 66.5 degree. This is the fourth belt, and this is termed as subpolar low pressure belt. Similarly, there is another subpolar low pressure belt in the southern hemisphere, and this is the fifth belt. And then there is the sixth and seventh belt. These are on the poles, and both are called polar high pressure belt. Polar high pressure belt in the northern hemisphere and the polar high pressure belt in the southern hemisphere. So there are 6 wind belts on the earth and 7 pressure belts on the earth. But before discussing the origin of wind belts and the pressure belts, let's talk about the basics of wind and pressure. What is wind and what is pressure? So here you can see what is a wind. You are very well aware that horizontal movement of air is termed as a wind. And what is air? You know, it's a composition of, or it's a mixture of various gases. On the other hand, if the air it moves vertically, then it is termed as air current. And secondly, what is pressure? Pressure, you must have studied in a school days. Pressure is a force per unit area. In physics, we say this is force per unit area. But here we are talking about atmospheric pressure. So what is atmospheric pressure? It is weight of the column of air, at any given place and time, and it is measured by instrument called barometer, and its units are millibar. And what does it mean by millibar? It is equal to the force of 1 gram on a square centimeter. Means on a square centimeter area, 1 gram force is acting. That is termed as 1 millibar in atmospheric pressure. And the normal pressure at the sea level is 1013.25 millibar, which is recorded. So what does it mean? It is equal to 1013.25 gram per square centimeter, or we can say approximately 1 kilogram per square centimeter. So this is the normal pressure at the sea, and it varies from place to place. It will be different at the landmass and different at the sea level. Now, what is the relation between pressure and temperature? Is there any relation? Yes, there is a relation between temperature and pressure. Basically, there is inverse relationship between the pressure and temperature. Pressure is inversely proportional to temperature. This is nothing. So if temperature increases, the pressure will decrease definitely. Or if the temperature will decrease, the pressure will increase. So both are inversely related to each other. When one increases, the other decreases, or one first decreases, the second increases. And as per law of equilibrium, winds, they move from high pressure areas to low pressure area. You're very well aware of that. It means that whenever there are high pressure areas and second there are low pressure areas, the wind will move from high pressure to low pressure areas. If high pressure area is here and low pressure area is down there, so wind will move from up to down, from this part to this part. So winds always move from high pressure area to low pressure areas. Okay, if we generalize it, we see at the earth, this is equator, you know, this is equator 0 degree and this is poles at 90 degree north poles and 90 degree south, this is the south pole. Equator is generally a warm area. Warm area means high temperature, so relatively it will be having low pressure, while the poles they are having very low temperature, meaning thereby high pressure. So what should be the direction of wind? The winds must move from poles toward the equator. This should be the general tendency. Similarly, in the southern hemisphere, the winds must move from poles toward the equator. But this is so in reality. Actually, initially, the geographers, they draw this diagram, like according to them, this variations, there is a thermal contrast theory that winds, it flows from high pressure to low pressure areas. So these are the cold areas and the wind will move from this cold means the high pressure areas to the low pressure areas, the hot areas, these are the equators. And here at this equator, the warm air, it would rise upward and finally it will go down as it at its cool down, it will go down and falls on the poles. Again from this part it will come to this equator, so it will create one convectional cell in the north hemisphere, in the second in the south hemisphere. So this was the general notion initially, but actually this is not the case. What is the case actually? You know, there is some deflection. In the actual, wind seems to blow from northeast. You can see, like here, let's divide in two parts. This is 0 degree and this is the north part and this is the south part. Here, what you can observe, the winds are not moving directly from this to this. They are generally tilted. They are like this. These are the polar easterly. Similarly, they are trade winds. They are like as if they are moving from the northeast. So they are moving from the northeast to southwest direction. But what we had discussed just, we saw that they must move from high pressure to low pressure areas, means they must move from the poles to equator in like straight way, but they are deflecting. So this is the very first question. We must know why, what actually is going on. There is deflection. And second thing, what we have observed, this is not a single belt, which we had seen in the last image. In this image, there is a single belt. According to it, the winds moves from poles to equator, but actually there are three belts. One is from this, second is this, and third is just opposite. We can understand why these winds are moving like this, because this is high pressure area, this is low pressure area comparatively, and this is the high pressure area, this is the low. So the winds are moving from poles to equator, but in between this, at this part, the wind is just moving in opposite direction. Why? Now we need to find out the reason for this. So we need to understand two things. Number one, why there is deflection in the direction of winds, and second is why one wind belt which is moving just in opposite direction. Why? For the very first thing, the reason is that for the deflection, the reason is Coriolis force acting on the winds. This is as per the Farrell's law. Farrell's law says every moving object in the northern hemisphere, it has a tendency to turn toward the right, and if it is in the southern hemisphere, it tends to turn toward left. So as per this law, the Farrell's law, the winds deflect, but which force acts on it? It is a Coriolis force. And why so? What is Coriolis force? Why there is deflection? Because of rotation of earth. Because if we talk about Earth rotates from west to east, and if we move from west to east, the general deflection, every moving object on this, like air or water, it will be pushed toward in the just opposite direction. We can say it's relatively it will push toward this direction. So if wind is moving from poles to equator, it will be deflected. This is the reason for the deflection of winds in the north as well as the south hemisphere. Then comes the second question, okay, why one wind belt, that is the wind belt of westerlies, basically why it is flowing in opposite direction. So now you know about the wind belts. There are trade winds, there are westerlies, and there are polar easterlies. In the north hemisphere, similarly in the southern hemisphere, there are trade winds, there are westerlies, there are polar easterlies. But to understand this, to understand these wind belts, we need to understand the pressure belts of the earth. So let's talk about the pressure belt. First of all, how many belts are there? You know, there are the total number 7. It is written 4, but these are basically 7. How? First is equatorial low pressure belt. This is just one belt, 0 to 5 degree north as well as the south hemisphere. So 0 to 5 degree north as well as the south. So this is the very first belt, and this is equatorial low pressure belt. Mind it, this is a low pressure belt. Second is this subtropical high pressure belt, and these are basically two belts. One is the north, second is at the south. So where it is found at 23.5 degree to 35 degree north as well as south latitude. So this is the second, and here it is the third belt, subtropical high pressure belt. We can number them. And now let's talk about the fourth and fifth belt, subpolar low pressure belt. This is subpolar low pressure belt at 45 to 66.5 degree north as well as south. So this is fourth and fifth pressure belt. And then the last two belts are around the poles, is the north as well as the south hemisphere. These are called the polar high pressure belt at sixth belt, and this is at 90 degree on the poles is the seventh pressure belt. So total there are 7 pressure belts. Why we are discussing this? Because we need to know why this westerlies are moving in opposite direction. We know about these winds, whether it is the polar easterlies or the trade winds, they are moving in a right direction. We know that why they're moving, because they're moving from the high pressure areas to low pressure areas. But the question is why westerlies are moving in just opposite direction, opposite to the trade winds. So to understand this, let's see how it happens, how the pressure belts they generate. So in this diagram, in this picture, you can see there are various cells. One is, you can see this is a Hadley cell, then there is a Ferrel cell in the north as well as the south hemisphere, and then third one is the polar cell, is the north as well as the south hemisphere. So these are the cells basically, and why these originates, and let's talk about them. If I see, okay, let us say this is a plane area. I'm standing on the earth, and we are observing it from this point. This is 0 degree equator, and here it is 90 degree poles. So this is 0 degree equator, and this is 90 degree poles. At 0 degree equator, what happens? 0 degree, basically the equator areas, they are the warm areas. So the warm air, they experience high temperature that causes the warming of air, and the warm air rises upward. So here it is rising upward. Similarly, let us say here it is rising upward. So it rises to a certain extent. As it goes upward, it starts cooling down. Why? Because the density of air decreases and the temperature of at high altitude also decreases. So at high altitude areas there will be low temperature, and what is the rate of that decrease in the temperature? That is called the normal lapse rate, which is 1 degree for every 165 meter of ascent. So at reaching some particular height, it starts descending. As it cools down, it becomes heavy, so it descends downward toward the poles in the north as well as in the south hemisphere. So from where the air rises, this generates one belt which is termed as equatorial low pressure belt. Here you can see, because from here the winds are moving upward, so these are the convection currents, and the force is not being applying on the downward but on the upward, so there is no pressure. These are the low pressure areas. But where the wind descends, it is descending downward, it is generating another belt. From here you can see the winds are moving toward this and they falls down, they subsides at this point and generate another belt. This is termed as subtropical high pressure belt, and this is what is generated, subtropical high pressure belt. Second, we can number it. This is the first equatorial low pressure belt, this is subtropical high pressure belt. And before talking about the third belt, let's talk about the fourth belt. This is the polar high pressure belt. At poles, you know, basically it experiences very low temperature, below freezing point, and at that temperature air never rises, rather it piles up. So there is the air masses, the cold air masses, and these are the areas where the temperature is very low and the pressure is very high. So the wind starts moving from these areas of the high pressure toward equator of the low pressure area. Similarly, the air which subsided at this point, which creates the subtropical high pressure belt, it starts moving toward equator as well toward poles. So this wind which is moving toward poles, it meets the wind which is coming from the poles. So at juncture where it meets, it creates another belt which is termed as this belt. This is subpolar low pressure belt, and here the wind rises upward and they move in two directions. One is toward poles and another is toward equator. So they create two loops, one toward this side and second toward this side. Similarly, here it creates complete loop. So in northern hemisphere, three loops are created. The very first loop, this is the first atmospheric circulation, which is termed as the Hadley cell. Then in the this is the second circulation, which is termed as the Ferrel cell, as written over here. And then third, it is the third circulation, so which is termed as the polar cell. Similarly, in the southern hemisphere, there will be three circulations, like you can see in this image as well. In the southern hemisphere, there are three circulations, three cells. One is this, and you know how these cells were generated, because here the warm air arose and it rises and then it starts descending and it piles up at this point, creating generating one belt, that is a subtropical high pressure belt, and from here it moves toward equator and second goes toward poles. Similarly, from poles it moves toward equator, and this which is coming from equator, they meet at this point and create another belt which is termed as subpolar low pressure belt and rises upward. As it rises upward, it moves toward the poles as well as toward the equator, completing two loops, here one and second at this point. So there are three loops which we have discussed in the north hemisphere. Similarly, three loops are generated in the southern hemisphere, and these loops are termed as cells. One is the Hadley cell, second is the Ferrel cells, and then there is the polar cells. So now you know, hopefully you must be knowing now how these pressure belts are generated, and from these pressure belts originates what? From there originates the wind belts. How? Now we can again draw this like this. Okay, if there is a pressure belt, these are the pressure belt I'm drawing, and these are the four pressure belt. This is the polar high pressure, this is the subpolar low pressure, this is subtropical high pressure, and this is equatorial low pressure. And from here, the air which rises, it descends downward and it starts moving toward equator, and due to Coriolis forces, it deflected toward right. So generating first belt, that is the polar easterly. Similarly, the poles, from poles, the winds move toward equator and create this belt. This is the polar easterlies, and when these wind it was subsiding, it moves toward poles, generating a second belt. This is the westerlies. Same thing happens in the southern hemisphere. So due to these pressure belts, the wind belts are generated on the earth. And you can again make it clear from this diagram. This is very clear. Okay, at this is the equator part, where equatorial low pressure belt, it is termed as doldrums, and this is the subtropical, second subtropical high pressure belt, also known as horse latitude, and this is subpolar low pressure belt, and these are the polar highs. And here you can see the winds are moving upward, and as they move upward, this is the warm air which is shown in red color, it cools down, it is shown in blue color, and it starts descending downward. At this point, at 30 degree, around 30 degree, it subsides, and at 30 degree it starts, it is divided two parts. One is moved toward the equator, second move toward the poles. Similarly, at poles, these are the cold areas, the wind moved toward the equator, and both these winds, they meet at a point which is the subpolar low pressure belt, and it rises upward. It starts again dividing two parts. One moves toward the pole, creating one loop. Second moves toward the equator, creating the second loop. So again, we can see these are the pressure belts which were generated, and due to these pressure belts, the winds starts generating, which moves on the surface of Earth. These are the winds due to Coriolis forces which are moving, which are deflecting toward the right. They are termed as trade winds in this part. Secondly, they are the westerlies in this part, and third is the polar easterlies. So hope you must have an idea now. You must be aware, a little bit aware, about how pressure and wind belts are generated, and how many wind belts are there, and how many pressure belts are there. That's all for now. We'll discuss further in the next class. Till then, bye bye. Thank you.